We are also seeing the latest stage of humanoid robot industrialization, the X-humanoid from Beijing, which has officially reached the level of serial production. In this footage, these are not laboratory prototypes, but already the 1,000th robot coming off the assembly line at a new verification factory covering nearly 10,000 square meters. This means China has moved from experimentation to a scalable robotic industry. The core goal of this hub is to close the gap between laboratory development and real-world deployment. Here, 4 critical challenges of humanoid robotics are addressed: mechanical stability, electronic reliability, serial assembly, and the integration of AI into the robot's physical body. In effect, this is a factory that trains not only neural networks, but the very process of mass-producing humanoid robots. If previously such machines were produced in dozens, now we are talking about hundreds and thousands of units, and this is a direct signal to the market. Humanoid robots are ceasing to be expensive experiments and are becoming an industrial product, marking the beginning of an era in which robots work alongside humans in logistics, factories, and service sectors. Before us is one of the most advanced humanoid machines in the world today, the robot Ameca, developed by the British company Engineered Arts. Unlike most humanoids, Ameca was not created as an industrial worker, but as a platform for human-AI interaction, a living showcase of what interaction between people and machines will look like in the coming years. Ameca's key feature is its realistic facial expressions and micro-movements. It has dozens of actuators in its face that allow it to convey emotions such as surprise, doubt, interest, and even irony. This is not simple animation. The robot analyzes human speech, intonation, and facial expressions in real time and responds with full awareness of context. In essence, this is a physical body for artificial intelligence. Inside, Ameca is a combination of cameras, microphones, and neural network models for speech and facial recognition, enabling it to orient itself in space and conduct dialogue almost like a living interlocutor. Such systems are already being considered as future digital consultants, reception robots, museum guides, and real-world interfaces for interacting with AI. What you see here is not just a flashy trick for the camera, but a real process of teaching a humanoid robot human movement. Unitree Robotics demonstrates the daily training of its humanoid robot, where the machine learns coordination, balance, and complex dynamic motions by replicating the actions of a human operator. Such training is a key stage in the development of so-called embodied AI, where artificial intelligence does not simply think, but learns to control a body in the real physical world. The robot analyzes human posture, movement trajectories, joint loads, and continuously adjusts its mechanics in real time. Behind the visual spectacle lies serious engineering, stabilization systems, balance control algorithms, high-speed actuators, and learning from human motion examples. This is exactly how the foundation is built for future robots that will be able to safely work alongside people in manufacturing, logistics, and service tasks. In front of us is the latest development in physical AI, a humanoid robotic arm from the startup RLWRLD, which sets an ambitious goal: to teach robots to operate in the physical world as naturally as humans do. Unlike classical industrial automation, there are no rigidly programmed scenarios here. The robot learns through neural networks, observation, and repetition of actions, gradually mastering real tasks. RLWRLD calls this the next stage in AI evolution, embodied intelligence, where the neural network does not just think but interacts with the real world through the robot's body. Such technologies pave the way for humanoid assistants capable of working in factories, warehouses, service environments, and even households. In essence, we are witnessing the first steps toward the moment when robots cease to be experiments and become part of everyday reality. We also see the latest development in mobile robotics, the XSTOA6, a next-generation wheel-legged robot designed to operate in the real, unpredictable world. Unlike classic humanoids that often lose stability on complex terrain, this robot combines two mobility concepts: wheels for high speed on flat surfaces and legs for overcoming obstacles. The XSTOA6 is equipped with an AI-based dynamic balancing system that analyzes body position, center of mass, and surface conditions in real time. As a result, it can move across sand, rocks, slopes, and uneven terrain without losing stability. Such capabilities are especially important for rescue operations, reconnaissance, patrol missions, and autonomous logistics in hard-to-reach areas. The developers position the XSTOA6 as a universal platform for further customization. Manipulators, sensors, cameras, and autonomous navigation modules can be installed on it. Essentially, it is not just a robot, but a mobile body for artificial intelligence capable of operating where wheeled vehicles get stuck and purely legged robots lose efficiency. Hybrid machines like this are bringing us closer to the era of autonomous robots working side by side with humans in the real world. In front of us is the latest development in industrial humanoid robotics. IREX, a robot created by Robotics specifically to work side by side with humans in real-world conditions. This is not an exhibition concept, but a platform designed for factories, warehouses, and service environments where precision, safety, and endurance are required. The key feature of IREX is its advanced multi-degree of freedom arm kinematics with a high number of joints. The robot is capable of performing micro-operations such as grasping small components, precise assembly, fastening operations, and simultaneously handling heavy loads. At the same time, its human-robot interaction safety system allows it to operate next to people without protective cages, reacting to proximity, gestures, and changing situations in real time. In essence, IREX represents a shift from classic industrial manipulators to a universal working body for AI. Such humanoid robots are created not for spectacular demonstrations, but for the real replacement of part of manual labor in manufacturing, logistics, and services. And it is precisely with systems like these that the mass introduction of humanoid assistants into the everyday economy begins. In front of us is also a new attempt by major technology corporations to bring closer the era of a home without manual labor. LG presented its new AI assistant robot called Cloyd at CES in Las Vegas, a prototype of a domestic humanoid assistant designed to take on part of household tasks. Unlike industrial robots, Cloyd is designed specifically for living alongside humans. It can move around an apartment, interact with LG household appliances, receive voice commands, and act as a physical interface for the smart home. According to the engineer's vision, such a robot will help with everyday tasks, from simple errands to interacting with connected devices such as washing machines, dryers, air conditioners, and security systems. At the core of Cloyd is a combination of computer vision, navigation sensors, and AI decision-making models. The robot analyzes its environment, recognizes objects and people, and in the future will be able to carry out household scenarios without constant human supervision. This is LG's first step toward the concept of the zero-labor home, a home where most routine tasks are automated